Now we've trained our first model, congratulations by the way, a good idea is to evaluate how it's going. And of course, we could look here, we can see the accuracy, it's getting pretty high. So the accuracy 100% on the training data set, but only about 63% on the validation data set. It's overfitting, but that's a good thing, right? Overfitting to begin with means our model is learning something. But since we've set up a TensorFlow callback, we can now utilize our logs folder. So if we go into Dog Vision and we go to logs, see how we've got two files there? This is from, I trained our first model yesterday. So this is where we've got logs from yesterday, and this is today's model. So, or the one that I've just trained when I had to reset this notebook. And so what we're going to do now is load up TensorBoard so that we can check out these log files and see how our models are performing. Now this is helpful if you're training more than one model. Of course, we can just, as I said, refer to this, and then if we ran another model, maybe down here, if we did model 2 equals train model, we'd get this output, this verbose output is what it's referred to, and we could just compare these two cells, but that's not going to really work over the longer term. So that's what we're all setting ourselves up about. So let's write a little heading here. Actually, we might do it in this cell. So we'll go checking the TensorBoard logs. And the beautiful thing about setting up this, like a TensorBoard callback, is that whenever we train a new model, it's going to automatically log its performance. So let's do a little write here. We go the TensorBoard magic function, percentage sign there, TensorBoard will access, we have to pass it the logs directory, but it will access the logs directory we created earlier and visualize its contents. We'll turn that into Markdown, Command MM. Colab cell shortcuts are slightly different to Jupyter. We go TensorBoard. Now, this is the magic function I was talking about. We have to pass it, the tag, to our log directory. And if you remember, we saved our logs. We just saw that. We just have to pass it the file path to here. So we could copy that, but remember we're in the habit of typing it out. And now, because this magic function is as if we're running it on the command line, we're not going to pass it the file name, the file path as a string. We're going to pass it as just non-string, just as if we were running this on the command line, writing it in terminal. So if I show you terminal, so just if we were running cd desktop, I'll zoom in there. See how desktop isn't in string format? Just the exact same there. So drive, my drive, and now the trick here is because we've got a space in my drive, we need to escape it using the backslash. So my drive, and then we're going to go /, we need dog vision, again, another space here, dog vision /logs. So hopefully this should load in to the dog vision logs folder. Launching TensorBoard, yes, that's what we're after. So this is a great tool to help us visualize how our experiments are going. It might take a little bit to load for the first time because you're going to see it's going to be a fairly graphical interface. Check that out. There we go. So see here on the left, let's just have a look at this interface. We've got a few options, TensorBoard. We've got inactive because this will actually update if we're training a model. We can refresh it if we want. If we come down here, these are the experiments we've run so far. So there's today, it's the 5th of February 2020, where I live right now. I just ran these. And if we turn off these are from yesterday. We're only going to get 2 graphs here. And one of them is the validation data set, so the validation performance, and the other is the training set, so the epoch loss. So these are epochs down here, and this is the loss value. Let's go back up. So remember the loss value we're trying to minimize, while the accuracy we're trying to increase. So if this epoch accuracy, if this is going up, That's what we want. But you see here how the training data set, the one in the red, is going up way further, almost to 1 compared to the validation data. That's where we can tell that our machine learning model is overfitting because it's learning the patterns in the training data far too well. So a later experiment would be trying to stop our model, our machine learning model, from overfitting. So one of the ways we can potentially do that is by using more data. So we'll try that later on. But as we ran more experiments, as we keep using our create TensorFlow callback, it's going to continually store logs in the logs folder. And now that way, if you find that one machine learning model, if we turn these back on, if you find that one type of model is really outperforming, so let's have a look at both of them just on the training data sets. So if we look here, they're basically following the same path, going down and down. That's with the loss. So the loss is going down. That's good. It means our model is learning something. And if we follow this, they're also following the same path here, which makes sense because we're using very similar data. Oh, well, because we set a random state way back up when we split our data. We're actually using quite the same right back up when we created our validation set. See how we use random state? So both of these experiments are using the same sort of data, so it makes sense that they get very similar results. So again, you can call this whenever in your notebook, whenever you've run an experiment. And that way, you can check out, okay, if I know I ran this experiment here, I can see, all right, so that model that we ran with these different values here in our create model, it got a certain results. And then if we altered this, we could see how that changes the results. So you can start to see over time how this gets more and more valuable at tracking your experiments and seeing how it does. Alrighty. So now that we've seen TensorBoard, we've seen how we can track our experiments over time. What I believe our next step is to do is to use our trained model to make some predictions. So let's do that in the next video.